All right, welcome to lesson 3.5, moles, Avogadro's number, and molar mass. This is going to be a pretty heavy math topic, but I did want to do a little bit of review of things that we already know, and I want to start with something called the mole. Remember that the mole is a unit based on the amount of a substance. And then we also said that 1 mole of any substance is equal to 6.02 times 10 to the 23rd representative particles. And remember, this number is also known as Avogadro's number. Basically figured out that if an atom is a certain size, and most atoms are relatively a certain size, then in order to get sort of one compositional unit of it, you need 6.02 times 10 to the 23rd. So basically what this means is, let's say we have 1 mole of carbon. That equals 6.02 times 10 to the 23rd carbon atoms, okay? And if we have like 1 mole of water, that means that we have 6.02 times 10 to the 23rd water molecules. Okay, remember water is also H2O. Basically, this idea of the mole is super important. When we talk about things called representative particles, this is kind of interesting to understand, but particles are just what substances are actually made of. So there's kind of 4, I guess there's actually a lot of representative particles, but I'm going to go through all of them. First one is atoms. These are used for elements. Like iron, helium, neon. Second one is a molecule or a compound. You can use those interchangeably. These are used for covalent compounds. So remember, 2 nonmetals make up covalent compounds. This is like H2O, CO2, CH4. And then we also have one called formula units. These are really used for ionic compounds. Okay. Ionic compounds are a metal and a nonmetal. NaCl, or like calcium carbonate. These are all ionic compounds. And then lastly, we have just regular ions. And these are used for charge elements. Like Na plus, Ca2 plus, S2 minus, etc. So depending on what type of substance you have, whether it's an element, molecule, formula unit, or ion, this representative particle up here changes, okay? So based on what your compound is, this representative particle changes. If we're talking about elements, we use atoms. If we talk about molecules, we're using molecules. If we're talking about ionic compounds, we're using formula units. It's pretty simple, but it can get very, very complex very easily. Now, the bulk of our kind of lesson today is to go over probably the most complicated thing we've done so far, and these are called conversions. And we use dimensional analysis for this, which I will show you how to do. And we did sort of talk about this at the beginning of the year, but it's going to be our new kind of norm to go into dimensional analysis. When we do dimensional analysis, we need a conversion factor. And conversion factors look something like this. They look like what we just saw earlier. 1 mole is equal to 6.02 times 10 to the 23rd atoms, let's just say. Okay? When we use this as a conversion factor, this conversion factor can be used two ways. It can be used as 1 mole over 6.02 times 10 to the 23rd atoms, or it can be used as 6.02 times 10 to the 23rd atoms over 1 mole. Okay, it just depends on whichever one of these we want to cancel. Usually what's on the bottom gets canceled. Okay? So I'll give you an example. And our example is how many molecules of H2O are in 2.50 moles of H2O. So first thing we're going to do, and anytime we see a math problem in this class, first thing I'm always going to tell you is start with what you're given. And in this case, you are given 2.5 moles, and more specifically, 2.5 moles of water. Okay? So this is number 1. Number 2, use conversion factors. Okay? We know that we're going from molecules, or from moles to molecules, so we need a conversion factor between moles and molecules. And the last thing is know your end results. Okay? Where it's asking for molecules, at the end of our problem, we should have molecules. So start with what we're given. We're going to write out 2.50 moles of H2O, because that's what we're given. Moles is on the top here. We want to get rid of moles and we want to go to molecules. And the way that we're going to do that is, I have to rewrite this because I want you to see how I'm going to do this. So we have 2.5 moles of H2O. We're going to draw our dimensional analysis table, and whatever is here, we want to cancel with what's down here. Okay, which means that we need a conversion factor, and our conversion factor is 1 mole of H2O equals 6.02 times 10 to the 23rd moles of H2O. And we knew that because we had it. We've been seeing this number. So we're going to put 1 mole of H2O on the bottom. And we're going to put 6.02 times 10 to the 23rd molecules on top. What's going to allow to happen is our moles of H2O are going to cancel, and we're left in molecules. When two things are on the top, we take this number and we multiply it by this number. So our math is going to look like 2.50 times 6.02 times 10 to the 23rd. And that's going to give us 1.51 times 10 to the 24th molecules of H2O. Okay? Now, what if this was reversed? What if we had how many moles are in 3.01 times 10 to the 23rd formula units of NaCl. Okay. Well, we know that 1 mole of NaCl is equal to 6.02 times 10 to the 23rd. So we always start with what we're given, 3.01 times 10 to the 23rd formula units of NaCl. We want to get rid of formula units, so we need formula units on the bottom. We want to go to moles, so we need moles on top. We know 1 mole of NaCl is equal to 6.02 times 10 to the 23rd. So these two, remember, are equal to each other, but we're going to use them in a conversion factor. And of course, our formula units of NaCl cancel. When something is on the top here and the bottom here, we divide, okay? And you don't need to multiply by 1 because that's just the number itself. So this math looks like 3.01 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. That gives us 0.500 moles of NaCl. And again, we ended with moles, it didn't cancel. Now, we can also do this with mass and molar mass. So remember, molar mass is equal to 1 mole of that specific substance. Okay? And we've been calculating molar mass, we should know how to do this. But my question is, let's say we want to go from moles to mass. Okay? And let's say, how many moles are in 100 grams of H2O. Okay. First thing I need to do is start with what I'm given, which is 100.0 grams of H2O. Now I need to figure out some kind of conversion factor. And if I remember, 1 mole equals the molar mass of H2O. which is 2 times 1.008 plus 15.999. So 1 mole of H2O equals around 18.016 grams of H2O. Okay. Now I have grams on the top here, so one of these is gonna go here, one of these is gonna go here. The question is, where do they go? Grams is on the top here, which means grams should be on the bottom here. So it's 18.016 grams of H2O over 1 mole of H2O. Okay? And the way that we do this math, again, we have 100 divided by 18.016. So 100.0 grams divided by 18.016 grams of H2O. That's around 5.55 moles of H2O. And again, if you were going from mass to moles, you would just flip things around. Last thing as far as like some of this kind of difficult math is, what if we want to go from mass to representative particles? Unfortunately, if we want to go to mass town, and let's just call it particle city, there is no straight line to get to from one to another. In order to do this, we need to go to a place called Moleville. Okay? So in order, you cannot go straight from mass to particle or particle to mass. You have to go to Moleville and then to Masstown. And sort of vice versa. Like, you would have to go to Moleville and then to Particle City in order for this to happen. So if we want to do this, we can say, how many molecules are in 50.0 grams of CH4, okay? And again, we're gonna start with what we're given. Really, anytime you see grams too, you should probably find the molar mass of it. So the molar mass of CH4 is 16.05, and I just did that by adding carbon and 4 hydrogens. So we can start with 50.0 grams of CH4. We have 1 mole of CH4 is equal to 16.05 grams of CH4. And again, it didn't ask for moles, it asked for molecules. And remember, 1 mole of CH4 is equal to 6.02 times 10 to the 23rd molecules of CH4. So I put 1 mole on the bottom to cancel, and 6.02 times 10 to the 23rd molecules on top. So we should have started with grams and canceled, because one's on the top, one's on the bottom. One's on the top, one's on the bottom. We're left with molecules. The way that we do this math is 50.0 divided by 16.05. And of course, this one's on top, so we multiply it by 6.02 times 10 to the 23rd. If you did this math right, you should get 1.88 times 10 to the 24th molecules. And the very last thing that I'm gonna do today is talk about something called stoichiometry. And it's just a very, very basic thing, I guess, for lack of a better word. It's a very basic principle in chemistry. This is the calculation of reactants and products in a chemical reaction. It also has to do with molar ratios. It also has to do with molar ratios of products and reactants. Okay, so let's look at a balanced chemical equation. Let's look at 2H2 plus 0, 2. It's time to kind of understand what these coefficients mean. These we just know as coefficients, but what these are also, these are moles of each substance. And what stoichiometry says is that for every 2 moles of H2, we only need 1 mole of O2. Okay? And if we mix these two together, we're going to make 2 moles of water. So, last thing that we'll do in this video is, if you have 4 moles of H2, how many moles of H2O is produced? So again, we have 4 moles of H2O. You can't do these without a chemical. You need a balanced chemical reaction for these. So 4 moles of H2O. Oh, sorry, it should be H2. So we have 4 moles of H2. And we want moles of H2O. Moles of H2, because we want them to cancel. We're going to look at these ratios between... All you have to do is look at the chemical equation and write it down. 2 divided by 2 is 1. So we have, for every 4 moles of H2, we have 4 moles of H2O. Okay, seems pretty simple. Gets really complicated. Do your best to work on the homework. We'll probably continue with the homework next time. See you later.